Okay, we are going to continue on with our exploration of figuring out the area of shapes and spaces. We will continue on with that today by doing a bit of a challenge called open-ended area. And this comes from yours truly. And here is our goal for the day. You'll notice that our success criteria is broken up into vocabulary that we would like to hear you use, into your specific goal for the day, and the big picture of what you are trying to accomplish. Here we go.
Today, we will continue attempting to reach for the big picture of finding the area of a rectangle with whole number side lengths by modeling with unit squares and by showing that the area is the same as would be found when multiplying the side lengths. Our goal is found on 3.3. We will construct a method to find the area of two shapes. Vocabulary that will help you with this lesson and should be used in your explanations is area, length, grid lines, unit squares, figure, and quadrilateral.
All right, so we are going to be working with those shapes that you have just heard. Figures and quadrilaterals should be familiar to you from second grade. Quadrilaterals, notice that prefix quad, that means four. So a quadrilateral is a shape with four sides. And a figure is just a drawing or representation of that shape. So our goal is to construct a method to find the area of shapes, okay? Here is how this looks.
Today we're going to talk about how to create rectangles with a given area. A given area is the area that we have been told should be in total when we complete the rectangle or the square. Today our directions say create 3 rectangles with an area of 12 square units. Remember, square units are called square units because when you look at both of the lengths and both of the widths, it will create a square of equal-sided units, lengths and widths put together. Today, we're going to look at how to create a rectangle with 12 square units as an area. I'm going to go ahead and use 12 squares and I'm going to arrange them until I get a rectangle that uses 12 squares. So far I've got 1, 2, I think I'm just going to keep going that way. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wow, look at that. That was pretty easy. So for this orange rectangle, what I've done is I have a width of 1 unit and I have a length of 12 units. So my multiplication equation for this rectangle would be 1 times 12 equals 12 units squared. So I've created one rectangle with 12 square units as an area. Now I'm going to work on another.
Remember, we talked about how square means that there are 2 dimensions, the length and the width. So sometimes instead of seeing SQ, you will see a floating 2 in the corner, and that represents the 2 dimensions, the length and the width. So there's a floating 2 that also means squared. So that's a new way that you could label your areas.
Now I'm going to think about what I can multiply by to get to 12. 12 is an even number, so I bet I could multiply by 2. So I'm going to set up a rectangle with 2 rows. 2, 3, 4, and I'm going to keep going until I get to 12. 5, 6, 7, 8, 9, 10, 11, 12. And look at that. Sure enough, I've got a rectangle that has a, oh, I didn't mean to turn that way, that has a length of 6 units, 1, 2, 3, 4, 5, 6, and a width of 2 units, 1, 2. So my multiplication equation that would describe the area of this rectangle is 2 times 6 equals 12 units squared. I've done 2 rectangles. I've been asked to create 3. So I'm going to use my songs to see if I can figure out another way to get 12. I've done 1, I've done 2. Let's try 3 as a factor.
So notice I just worked up the factors here as I was solving. I noticed that the factor of 1 worked when there were 12, because I can count by ones 12 times. Then I went up to 2. I can count by 2 6 times. 2, 4, 6, 8, 10, 12. Now I'm going to move up to my next factor, which is going to be a 3. So I'm going to have a dimension or a length of 3, and we'll see if that works.
3, 6, 9, 12. Hey, I used the 3 songs and said 4 lyrics. So let's set up rows of 3. 1, 2, 3. 4, 5, 6, 7, 8, 9. Oh, I need to duplicate some squares. 10, 11, 12. Hey, look at that, 12 square units. And again, this time, I have a length of 4 square units, 1, 2, 3, 4, and a width of 3 square units, 1, 2, 3. So the multiplication equation that would describe this rectangle is 3 times 4 equals 12 units squared. This is how you can create rectangles with a given area using more than one set of dimensions.
So all of these have an area of 12 squares. I want you to notice how different they look. Okay? This is very similar to if you were to think about a piece of paper. If this were an area that we were looking at, if I were to cut this piece of paper and rearrange it, I still have the same amount of paper. It might look different, but it is just in a different order. Okay, so it's the same amount, it just appears different. And then I could even take it further if I wanted to, and I could rearrange it another way. I still have one sheet of paper, but I could make it look different. This has the same area still. If I were to put it back together how it originally was, we have the piece of paper. So it is possible to have the same area or amount of space look very differently, okay? And that's what you're going to figure out today.
When looking at
You are also going to figure out how to determine if a shape has a given area and what that can look like, knowing that there can be more than one view of that shape.
rectangles to find the area, this is a great opportunity for us to practice our multiplication fluency. Our directions ask us to use the pin to circle each rectangle with an area of 20 square units. We know that area is found by multiplying length times width. So for this rectangle, I can see that I have a length of 10 units times 2 units. 10 2 times is 20. So this has an area of 20 units. So I can circle this rectangle as having an area of 20 square units. Let's check our next rectangle. This rectangle only shows one dimension. That's because it's a square. And we know that squares have 4 sides of equal length. So if this side is 10 units, this side would also be 10 units.
Yesterday, this tripped some of us up. Yesterday, I had some people tell me, Miss Sousa, I can't multiply because this is blank. There's nothing there. When it is a square, we know that squares have 4 of the same size sides. So on squares, they might only show you one of the dimensions because they're expecting you to understand that squares have the same size sides. Okay? So if you are seeing a shape that is a square and there's only one dimension given to you, You can totally figure out the multiplication equation by multiplying that same number twice against itself, because squares have the same size sides. The only exception to this would be if we had a rectangle and perhaps there was a question mark. Then we're trying to figure out what the total area is. But when it's a square, they have the same size sides, okay?
10 times 10 is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 units squared. 100 units squared is more than 20 square units, so this is not an example of a rectangle with an area of 20 square units. Let's look at the pink rectangle. The pink rectangle has a width of 4 units and a length of 5 units. We know that 4 times 5 is 4, 8, 12, 16, 20. 20. So this has an area of 20 units squared. We can circle this as an additional answer to the problem. Let's look at the green rectangle. This has a length of 5 units and a width of 3 units. When we multiply 5 times 3, 5, 10, 15, we get 15 units squared. Again, this is less than 20 square units, so this is not an example of a rectangle with an area of 20 square units. Again, finding areas of rectangles is a great opportunity for you to practice your multiplication fluency to determine the proper area units.
Okay, so that's a reminder again that we can find the same area even though it looks different, just like that piece of paper. This is one piece of paper, whether it looks like this or like this, it still has the same area, it's just been arranged in a different way. Are there questions about what you saw and how area can appear differently on shapes? Any questions or anything that we need more information about? Okay. This is going to be a pretty fun, creative activity for you to complete. So go ahead and open up your Seesaw, and you have an activity that has been released to you called Area of Rectangles and Squares. Area of Rectangles and Squares. We've done the With Your Teacher section. We've reviewed the success criteria. We've looked at how to create rectangles using unit squares, and we've looked at how to determine if a rectangle has an area by multiplying its dimensions. You're getting ready to work on this section. You're going to add the response, and on slides 1 through 4, you're going to use squares to create a rectangle, just like you saw me do in the video. On slides 5 through 6, you're going to circle the answers or the rectangles that have the given dimension on the slide. On slide 7, as always, you will reflect on your success criteria. I want to work through one of each of these together. So we're going to go ahead and take a look at slide 1. I want you to look at slide 1 with me. Give you a moment to get there. We're going to be on slide 1. It says, use the GeoBoard to create a rectangle with an area of 32, I'm going to go ahead and highlight that, square units. Then it asks me to label the length and width with the pen tool. So I have 2 things to do. I have to create that rectangle, and I have to label the length and the width in order to be done. Levin, a question.
So are we doing this all together, or is it independent work or breakout room work?
Combination. We're going to look at some together first and see if there are any questions, and then I will release you to work on some in a moment. Okay, thanks for checking. Alrighty, so I'm going to think about how I could do this. In the video, we saw a very long, skinny rectangle. The only problem is I don't have 32 spaces, so I can't make a rectangle that's going to go all the way over to 32. So I'm not going to do a rectangle with a width of 1. I'm going to think through what could be multiplied by, what could multiply to equal 32. So I'm going to check, my 1s won't work. I could do 2s because it's an even number and it ends in a 2, but I'm going to try to challenge myself and see if I can figure another way. Let's try the 3s. We're going to see if we say 32 when counting by 3s. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, plus 3 more, 31, 32, 33. Nope, 30 or 33. So I can't use the 3s. Let's try 4s. 4, 8, 12, 16, 20, 24, 28, 32. I said 32. So I can use 4s. So let's go ahead and create a width of 4. We're going to line up 4 rectangles just like this. And I don't care where you do this. You could put it up in the corner where I have it. You could put it over here in the center of your board. I don't care. As long as you have 4 rows set up or 1 column of 4. And I'm going to go ahead and label that right now with my pen tool. I think it's cool to write in whiteout, so I'm going to do that. I have a dimension of 4 right now, because I know that 4s will work because we counted by 4s and we got to 32 evenly. 4, 8, 12, 16, 20, 24, 28, 32. Okay. So now I'm going to keep creating those columns of 4 until I'm out of blocks. So that's 7 and that's 8. Okay, so I have 8 blocks. I need to get to 32. I'm going to keep going. 9, 10, 11, 12. You guys keep building yours along with me. So I'm at 12. I got to get up to 32, so I'm still not done. 13, 14, 15, 16. I'm still not at 32, so I'm going to keep going. 17, 18, 19, 20. I'm still not at 32, so I'm going to keep going. Oh, I'm looking at your rectangles right now, and some of you are creating triangles, and some of you are putting spaces between like this. That won't work. Your directions ask you to create a rectangle. See right here, a rectangle. That means it needs to be connected, and it can't be spaced out all over the board. Okay, so go ahead and make sure that if you were doing that, fix it right now. I see several screens that were putting them anywhere they wanted and randomly. It has to be a rectangle. Our directions are about rectangle areas. Awesome, I see some of you fixing that now. Okay, so I'm at 4, 8, 12, 16, 20. I'm going to keep going. 21, 22, 23, 24. I'm not at 32, so I'm going to keep going. Make sure your square units are touching and are creating the shape of a rectangle. 25, 26, 27, 28. Okay, I'm still not at 32. I'm at 28, 29, 30, 31, 32. Hey-oh, look at that. 32. I've gotten to 32. Now I need to label my length. I've labeled my width right here, but I have not labeled my length. So I'm going to count how many squares this is. 1, 2, 3, 4, 5, 6, 7, 8. So there should be 8. So my length is 4, my width is 8. And this works because we know that 4 times 8 equals 32 units squared. Okay. A few tips: if you accidentally delete a square like that, I accidentally hit the backspace, you can use this arrow in the top to put it back, or you can choose another square and click on duplicate and it will add a square for you. You can also Control C for copy and Control V for view, and it will put an extra square there for you as well. So there are several ways to make more squares. So if you, for some reason, don't have 32 because you accidentally deleted some, you can add more yourself. Okay. What questions can I answer about this one that we just solved? Okay. Yes, Aiden L.
I only got 15 squares.
Yep, I just went over what to do if you need more. Do you remember?
Mm-hmm.
Okay, go ahead and get that done then, kiddo. All righty. In a moment, I'm going to open up some breakout rooms for you with a partner, with one other person, and you're going to solve slide 2 with your partner, just slide 2. You're not going to do 3, okay? Slide 2 says, use the GeoBoard to create 2 rectangles with an area of 18 square units each. So I'm going to see 2 rectangles on your board that represent 18 square units that have an area of 18. And I just made those rectangles up. I don't even know if those are 18, so don't use those. Okay, so you and your partner will drag some squares and you're going to put 18. What I might do is think about my factors first, just like we did together on this one. Think about what you can multiply by to get to 18. What numbers can you repeatedly add to get to 18? You are also going to label the length and the width, just like we did here, okay? When we get back, I'm going to have several of you share your screens so we can see all of the different possibilities of how to create rectangles. Because as we learned in this instructional video, there is more than one way to create a rectangle with a given area. So we're going to see how many different rectangles we can come up with. I do want to make sure that you remember it says rectangles. Okay, so I'm not going to see 18 squares spelling out smiley faces. That's not a rectangle. Okay, so you need to make sure that you have your unit squares arranged so that they are touching and connected to form a rectangle with a length and a width. Okay. Any questions on that expectation before I release you to work in your rooms together with your partner? Any questions on that expectation? Aiden G.
Can you go back to the first page so
Yes,
I
I
can see it?
There you go.
So, I'm done.
Okay, great. All righty, so I am going to send you in to your breakout rooms now. You are going to work on slide 2. Show me with your fingers what slide you're going to work on. What slide? Good. Slide 2, only slide 2. Don't move on. I'll give you guys about 4 minutes. 4 minutes, I think, is a fair time to create 2 rectangles with an area of 18 square units each. Okay. All righty, I will be popping in and out to check in with you and see how you are doing. Guys, I just lost all of that because I didn't record and none of y'all told me. So Levin's beautiful example and Terrence's creative mind was lost to the world of YouTube. It's miserable. All right, let's see. Tell me if you got a different dimension. Did someone get a different dimension? Aiden G, did you want to share yours?
Oh, I did. Can I share my screen?
You can.
For him, can I?
So I put, so I made like a square type that looks like it has been stretched.
Okay. And what are
And
the dimensions?
so the dimension is a square because I put 2 at the top and 9 going down.
Okay. So your dimensions are a length of 9 and a width of 2. And your label was square units. Okay, and this would equal 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. And also 9 plus 9 would equal 18. Awesome. A very different rectangle than what we have seen. Thank you, Aiden G. Aiden L, and then Leah, and then we're going to move on. Aiden L, would you like to share your screen?
Yes.
Okay, show us what you came up with, sir. All righty. So tell us what you have.
I made groups of 4.
Why did you start with 4s?
Because I knew 4 plus 4 was going to equal 8. So I just keep doing it because it was going to be easier for me to go to 18. And then I figured that 3 times 6 was 18 because of the blocks.
Okay, so you broke this down into the tens place and the ones place. You knew that your ones place of an 8 could be made with 4 plus 4. And then you knew that you would have 10 left. So I see that you broke that up into 2 groups of 4 and 1 group of 2. So Aiden, this is beautiful in terms of how you came up with getting to 18. What I want to see now is what Terrence needed to do as well. Let's push all of those together so that all of them are touching. And that way we have that dimension of 6 times 3. So that was a great way to group those together to get up to 18. Now we just need to push them so that it's one shape. Okay, so push those together. But man, breaking it down into tens and one places. Look at your guys' math understanding. Strong. Thank you, Aiden L. Leah, close us out, sis.
Hang on.
All righty.
There.
We are not seeing your screen yet. There we go. Now we are. All right. Show us what you came up with.
So, I counted up, I did 1, 2, 3, 4, 5, 6 of these. And then, I added another line, then another line. And then I was like, I was going to do 4, but then I noticed it added up to 18.
So you kind of use that strategy of repeated addition. You did a group of 6, and then another group of 6, and then another group of 6, and you know I'm at 18 there. Okay, so multiple ways to think here. Leah showed us repeated addition. Aiden L showed us breaking it into the tens and the ones places to get the number of blocks we needed. Terrence, you showed us how to chunk into smaller sections before we put them together. Levin, you showed us how to count by the factors. Aiden G, you showed us a way that none of us had used, which was a different dimension of 2 and 9. So here are the 2 rectangle possibilities that you could have created for 18. You also could have created 1 times 18, but the board's not big enough. So you could have stretched this all the way 18 out, but our board's not big enough, so that didn't work. So these are the 2 rectangles that I should see on your board in some way. I don't care if they're this way or if you turned it so it was tall or turned this one so it was on its side. But the 2 ways to create a rectangle with an area of 18 are 9 times 2 and 3 times 6. Those are your 2 multiplication equations of length and width that will get you to 18. Okay. Today, you are getting ready to complete the rest of these independently. Slide 3 says to create 2 rectangles with an area of 30 square units each. Notice that word each. That means each of the 2. So I'm going to see one rectangle and I'm going to see another rectangle. I'm not going to see 2 parts of a rectangle that you squish together to equal 30. Okay, it's going to be 2 separate rectangles that equal 30, which means you should have 60 squares, 30 plus 30, okay? 2 rectangles with an area of 30 square units each. Label the length and the width, just like we have been. On slide 4, you're going to try to create 3 different rectangles with an area of 24 square units. One here, another rectangle here, another rectangle here. And each of them should have 24 square units. Okay? On 5 and 6, you're going to multiply the dimensions to see if they equal what has been shown up here. If they have an area of 12 units squared, you are going to circle that rectangle. On slide 6, you're going to circle the rectangles that have an area of 18 units squared when you multiply their dimensions. We just did this one together right here. That's a little bit of a cheat for you. On slide 7, determine the area of a shape by multiplying the length and the width. You're going to tell me, I did meet this goal or I did not meet this goal. So tell me how you think. Either yes, I did it and I know it because, or no, I didn't do it. I was struggling because, and let me know. Okay? This is your assignment. So you will complete slides 3, 4, 5, 6, and 7. And remember, each one of these slides has more than one answer. This says create 2 rectangles. This says create as many as you can. This says circle all of them that are right, circle all of them that are right. Okay, so you're not just creating one rectangle like we did at first. I should see more than one. Okay, alrighty.